This is Honors Geometry, section 15.3. Find the volume of pyramids and spheres. Homework assignment. Match the following terms of the diagram. The slant height, where you take the face of one of these fellas, a face that is not the base, and you find the distance that is, the perpendicular distance the base is to the vertex. So that would be D. The apex, well, that is the point that's furthest away from the base, that's F. The height of this pyramid, well, that is the perpendicular distance, shortest distance that the apex is to the base, so that's E. The lateral edge, well, that's an edge that is not on the base. A face, that's this gray area, that's any of the polygons that make up the pyramid. And the vertex, there's many vertices on this. I mean, F's even a vertex. This is a vertex, so is this, so is this. C is one that's named here. Two pyramids with the same base are side by side. One is a right pyramid, that's this one, and the other is oblique, that's this one. If the oblique pyramid has been tilted to an angle of 80 degrees, what's the volume relationship between the two pyramids? Well, since they have the same base and they have the same height, h, they're going to have the same volumes, because to find the volume, we're going to take 1/3 of the base times the height. They have the same base, they have the same height. It doesn't matter if it's tilted. Number 3. Determine the volume of the following. So we have a rectangular pyramid. The base here is 8 by 6. So to find the area of the base, it is 8 times 6, which is 48. To find the volume of the pyramid, it's 1/3 of the base times the height, base being the area of the base. So it's 1/3 of 48 times the height. And this height is unbeknownst to us. However, if we make this right triangle in here, and if this dimension is 8, this height is going to cut that in half, which makes that 4. And then this diagonal, the hypotenuse is 10. So we can use the Pythagorean theorem to figure this out. So 4 squared plus h squared is the hypotenuse 10 squared. So 16 plus h squared is 100. Subtract 16 from both sides, square root both sides. 84 breaks down to 4 times 21. 4 is a perfect square, so we get h is a positive 2 square root of 21. Throw that in there. 1/3 of 48 is 16. 16 times 2 is 32, so we get 32 square roots of 21 cubic centimeters. Number 4, a rectangular hexagonal pyramid. So this is going to be tough, because to find the area of the base, we're going to have to use the formula for area of a regular figure. And to do that, we got to find the measure of the apothem. And to do that, we got to find the central angle. Here's how you do that. 360 divided by the number of sides. The apothem, which is right here, is going to cut that in half. So half of 60 is 30. It's a special right triangle. Opposite 30 is 4. It cuts the side in half. Opposite 60 would be that times the square root of 3. So the apothem is 4 square roots of 3, which is what this is right here. Remember to find the area of this base, which is a regular polygon. It tells us that, a regular hexagonal polygon. It is 1/2 the perimeter times the apothem. The perimeter can be found by multiplying the length of one side times the number of sides. 8 times 6 is 48. So we have 1/2 times the perimeter times the apothem. Half of 48 is 24. 24 times 4 is 96. So we get 96 square roots of 3 square centimeters is the area of the base. Which leads us to define the volume. It's 1/3 the base times the height. So 1/3 of 96 square roots of 3 times the height is clearly marked here as 20. And we're going to get 640 square roots of 3 cubic centimeters. Number 5. It's a square pyramid. So the base is a square. Dimensions are 10 by 10. So the area of the base is 100. To find the volume of the period, it's a third of the base times the height. The base we just found is 100. The height we were not given. But we were given this is 60 and this is 90, and the hypotenuse is 10. It's a 30, 60, 90. If the hypotenuse is 10, short leg is half of that, which is 5, and the long leg is the short leg times the square root of 3. So this height is 5 square roots of 3. 3 does not go into, 100 or 5 evenly, so we get 500 square roots of 3 divided by 3 cubic centimeters. Number 6, the volume of a sphere is 4/3 pi r cubed. Radius is 6. 6 cubed is 216. And you can divide 216 by 3, and then if you multiply it by 4, you get 288 pi cubic centimeters. Number 7, to find the volume of a semi-sphere, it's half the volume of a sphere. So it's half of 4/3 pi r squared. Whoa, I got pi r squared there. That's bad. This should be cubed. Just going to make this 1,000. Just going to make this 2,000. Wow, that is bad stuff. So a half, you can divide 2 into this, it goes 1 time. You can divide 2 into 4, it goes 2 times. So now we have 2/3 times pi times the radius cubed, not squared. 10 cubed is 1,000. 2 times 1,000 is 2,000. 3 doesn't go into it evenly, so we just leave her like this with the pi there in the cubic centimeters. Number 8, it's a square pyramid. We got to find the volume by taking 1/3 the base times the height. The height we don't know, and the base we don't know. To find the area of the base, it's the base times the dimensions of the base and the height, which is 256, 16 squared. And this height, well, we know that this hypotenuse is 17. If the length of this square base is 16, half of that's 8. This is a Pythagorean triple, an 8, 15, 17. If you don't recognize that, use the Pythagorean Theorem and you'll figure out this is plus or minus 15, and we know it's a positive 15. So the height's 15. Multiply those little fellows together and you get 1280 cubic centimeters. Number 9, boy, I gave you lots of room because there's lots of work. It's a terrible problem. To find the volume, we got to find the volume of the pyramid, which is up here, and the volume of the prism, which is here. Both of those have the same base. So to find the area of the base, which we are told is an equilateral triangle, if we draw the height, by the way, to find the area of a triangle is 1/2 base times height. If you draw the height in this, the altitude, it's also a median, it cuts the side in half, makes a 90-degree angle, cuts the angle in half. Equilateral triangle, all the angles are 60, half of 60 is 30. It's a special right triangle, a 30, 60, 90, but you never heard of that before. If the hypotenuse is 8, the short leg is 4 because it's half of it, and the long leg is the short leg times the square root of 3. So the area of this triangle is 1/2. Oh, that's not right. Got a mistake here. It's the second one. Good thing I'm doing this. The base is 4. It's going to be 4 times 4 is 16. 16 divided by 2 is 8. So that should be 8 square roots of 3, which changes this and this. What did I have as that before? 16. Which means this is 24. And that means this is 112. I believe that's right. Yep. I'll explain this problem some more. I just want to try to fix the mistakes that I had. It's 24. This is 112. It's going to be 236, I believe. 136. And the units were cubic centimeters. Anyhow, sorry about that. Getting back to the problem, I'm just trying to fix some mistakes there. Once you know the area of the base, that's the hardest part. For the pyramid, which is this part here, it's 1/3 the base times the height. The height it shows is 9. 1/3 of 9 is 3. 3 times 8 is 24. So it's 24 square roots of 3 cubic centimeters. Volume of the prism, which is this shape here, we know what the area of the base is, 8 square roots of 3 times the height of 14. We're going to get 212 square roots of 3. Add those together, because the figure consists of both of those, you get 136 square roots of 3. See if I messed up this one. The base, well, big picture-wise, to find the volume of this figure, it's the cylinder and a semicircle. Semi-sphere, I should say. The base in each of those is the same. It's a circle. So it's 4 squared, 16 pi. 4 squared times pi is 16 pi. To find the volume of the cylinder, it's the base times the height. So it's 16 pi times 5, which is 80 pi. For the semi-sphere, it's half, because it's half a sphere. 4/3 pi are cubed. 4 cubed is 64. Half of 4 is 2, so that's why it's 2/3. And then 2 times 64 is 128, so we get 128 pi over 3. Add those together. I get common denominators, multiply this by 1 in the form of 3 over 3. Give me 240 over 3. Add the tops, leave the bottoms the same, and that's that volume. All right, we got 2 more humongous problems. Number 11, to find the volume of the figure, let's look at the big picture first, which is here. We got to find the volume of this rectangular prism, square prism, and then add to it the area of, well, I'm sorry, that's a pyramid. This square pyramid, and then add to it the square prism. Both of those, we got to find the area of the base. Same bases, which is convenient. The base is 12 times 12, which is 144. So replace the b in each of these with 144. Prism, it's the area of the base times the height. The height's 5, we get 720. For this pyramid, it's 1/3 the base times the height. This height is 8, so it's 1/3 of 144 times 8, which is 384. Add those, you get 1,104. Number 12, 2 tennis balls inside of this cylinder. What's the volume of the air in the can? So that's the volume outside of the balls, but inside the can. The base for all 3 of these shapes, 2 of those shapes being identical, is a circle. Find the area of a circle is pi r squared. So let's think about how we figured this out. This whole thing's 48. That means this ball, each ball is taking up half of the space, which is 24. If the diameter is 24, it means the radius has to be 12. So 12 squared times pi is 144 pi. That's the area of this circle. For cylinder, multiply that by the height. It's 48. For the sphere, one of the spheres, it's 4/3 pi r cubed. So it's 4/3 times 12 cubed. 12 cubed is 728. You can divide that by 3 and multiply it by 4 and get 2,304 pi. The volume of the can, the air that's in the can, is the cylinder minus 2 times the volume of a sphere. So we double this, we subtract, we get this. Have a nice day.